Cool. Oops. So welcome back, HackCloud. Very exciting. Uh, I'm so thankful that you're all here during midterms. Like that is crazy. Yeah, this is the third session. We're covering serverless computing. It's very exciting. It's a big topic. Very cool, very popular nowadays. My name is Anar, by the way. That's Andy. He's gonna be presenting later. But yeah, before we get started, just a quick announcement that, well, first of all, this slide is new. I did not know the slide was there until 5 minutes ago. We need you to do feedback, preferably at the end, when after you've actually witnessed the presentation. But we also need it for you to, in order to get food. I don't know if we have food today. I thought we would. Is it like outside or something? Yeah. Okay. Yeah. So you're going to get food later today. And that's because a lot of you filled out this form in previous weeks. So yeah, just scan that. I'll go back to it at the end too, if you prefer to do it at the end, which I recommend that you do. And also, straight from our mother branch, ACM board, they requested that we talk about CS Town Hall, which is an opportunity for you to give feedback to CS professors if there's something you don't like about the CS department, such as some of their classes. This is a great opportunity to tell that to them. For example, in previous years, people have complained about 35L, the class, because it was taught mainly by TAs. And now that's not the case anymore because they realized it was terrible. So yeah, I think there's going to be food there at the town hall. Not sure, but hopefully there will be. If you're interested, fill out this RSVP form, another QR code to scan. By the way, it's going to be May 10th at 6 p.m. in Hmong Learning Center, which is just downstairs in that big lecture hall, if you're not aware. Okay, I'm gonna leave that up for a second. If you're interested, I highly recommend, by the way, it's a lot of fun. Also, as you're probably familiar, we are doing candy. I know you all like candy, but if you raise your hand, answer a question, ask a question, anything like that, you can get candy, which is very cool. And also pizza later, as we mentioned before. Yeah, so I think we are good to get started. First up, just some quick review of 35L. I don't know if you all took 35L, but we're just going to talk about one topic, actually one lecture, I think, of 35L, which is about the client server model. So first of all, what is a server, right? Like I think we're doing serverless, right? So I think it's probably useful to understand what a server is. It's basically just a computer, right? Just a computer. But that's not the most satisfying answer, right? Like, how can you differentiate something that is a server and something that is not a server? One of these is a server. I'm going to give you the opportunity to guess which one is the server and which one is not. If you get it right, I will give you candy. If you get it wrong, I will also probably give you candy, but less or worse one that I don't like as much. So any volunteers? I think you look like you like candy. So I'm gonna pick you. Which one do you think is the server? You're the left one. Yes. Unlucky. I'm sorry. Not the server. How do you feel about milk duds? Okay, I think that's the perfect lukewarm response for a wrong answer. There you go. Cool, yeah. So the right one is the server. The left one is something I'm going to call client. Just an arbitrary name, but basically the client wants to get something done, right? It wants to say, get some data, and it knows that the server has it stored on its files somewhere. So it sends a request over to that client, and the server is going to just listen out for that request. And then it's going to do something behind the scenes. It's going to, dig down deep into its file system and pull out that data and send it back to the client in a cute little package called a response, right? So that's all that makes it a server, right? It's just listening out for for requests, and then it's performing some task and sending a response back to the client. Cool. So just to recap, a server is a computer that we task with listening and responding to requests. that can be a request to perform some task or to get some data. And these requests come from other computers that we call clients. This is all part of something that we call the client-server model, right? Okay, so now that we have that out of the way, wait, first of all, any questions? I'm assuming you're all familiar, but I don't want to overstep. Okay, cool. So what is serverless? The name kind of suggests that we're just not using a server, right? Like, what does that mean? Does that mean that we can't do data persistence? Does that mean that we just have a static site, or potentially that all the logic is just on the front end? No, none of that is true. That's all. I mean, there's a time and a place for a static site, but we're not going to worry about that right now. The truth about serverless is that it still has a server, right? The only difference is that it's abstracted away from you for your convenience. So all you have to worry about is just writing the code for it rather than maintaining it and making sure that it doesn't go down and stuff like that. So the cloud provider that handles the serverless stuff is going to handle everything for you. That includes scalability, which is, can you handle a sudden surge in users, something like that, or potentially a sudden drop in users? I don't know. And availability, which is your ability to perform a task at a certain time. Basically, this means, is your server up when you need it to be up? So both of that is going to be handled by your cloud provider. It's pay as you go, which is really nice. Yeah. Oh, dude, the emoji is like the weird Windows emoji. That's so, oy. Anyway, so why would you want to use serverless? One reason is that, well, in the traditional model, you have to maintain the server yourself, right? Like I mentioned, that's just really annoying. There's a whole reason, there's a whole career behind that. No one wants to do that. In serverless, the provider maintains the server for you. You don't have to worry about it, right? And then in both of them, in the traditional model and in the serverless model, you write code for your server functions, right? Like your endpoints, stuff like that. So, but the difference is in serverless, that's all you have to worry about, right? You don't have to worry about anything else. In the traditional model, it costs money to keep it available at all times, right? Like you have to continuously run your server. And if you aren't running it, you're not paying and you're not gonna be able to serve people. But in the serverless model, it's pay by use, highly available. It is always available up whenever you need it, which is really nice. And again, serverless, they handle the scaling for you. Traditional, you have to buy a bunch more servers if you suddenly have a surge in users, which is not fun. One upside I will say of the traditional model is that you have a lot more control, which can be nice if you're into the details, stuff like that. In the serverless model, you have less control and someone is constantly over your shoulder. But anyway, so our platform of choice, as you probably know, is AWS. AWS is great. We love it. And the serverless option in AWS is AWS Lambda. So just lets you write functions for your server, kind of like endpoints, which is great. Here are a bunch of use cases which are directly from the AWS website. I'm not going to read it off for you, but you are welcome to read it off if you would like, if you care. One I do want to highlight is the web applications one, which is what we're going to be working on a demo, or what the demo is going to be on today. So you can use Lambda for your web application backend. Yeah, click this link. Actually, do we have a link to the slides? Is it on Discord or like anywhere? Okay, cool. Yeah, if you want that, check that out. But yeah, I'm not going to bother to read off everything. And another thing, which is very cool, is AWS API Gateway. Basically just lets you host an API on AWS. And you can invoke Lambda functions to do that. So basically, it's your host for your serverless stuff, right? All of this. Oh, and as a side note, you can make RESTful APIs and WebSocket APIs. A WebSocket API, if you're not familiar, is a two-way connection. So if you're making something like a chat app or something like that, it's very handy for that. we're going to be focusing on RESTful APIs, so let's not worry too much about the WebSocket stuff. And this is all, I think, easier shown than explained. So let's just do a quick demo. I'm not going to do it. Andy's going to do it. So let's get going.
Okay, so cool. We're gonna do a pretty simple demo today. Here's my scuffed GitHub repo slide. Satyan should have posted the slides in Discord. So if you go to the slides, go to like sort of the end, you can click on this link. There's a little write-up, so if you wanted to follow along, you can. But yeah, let's just get straight into it. I'm just gonna open a new tab so we can do this. There's not going to be any like fancy front end. I'm pretty much just going to do some front operations. So like, maybe make a GET request, and to do like all the testing, I'll be using Postman. So no front end, but to get started, let's just go to AWS. If we just go to the front page, we can sign in, which you should already have an account. And then you see I've had a bunch of recently visited services, but if we go to services, the first thing we're going to want to do is, because we need something to like interact with when we're, calling our function. For this, we'll just be using a simple DynamoDB table. The focus isn't on Dynamo, so I'll just be like creating it, but you can follow along. You just go to DynamoDB service, create a table. For the table name, I'll be using product inventory. And again, all of these sort of specifics are in the GitHub repo if you miss something. And some stuff like this table name, because we're manipulating a table in the code, it does matter. So if you want to change this name, you can change the code. But yeah. We'll also need like a partition key for our table. And for this, I'm using product ID. And we'll just go ahead and use default settings for our table. And that should be pretty much it. So I'll just go ahead and click create a table. If everybody's good with that. And don't worry too much about this. It's really just like our little mini database. But to get into the actual serverless part, after it creates the table, it's a little too far. It takes like a minute. Cool. It's created. We'll go to Lambda. If you just search Lambda, and this is what we write our serverless functions in. So this is the beautiful front page, and under this Get Started area, you can click Create a Function, and then it brings up all this like configuration you have to do. We'll just be authoring from scratch. Our function name. This isn't probably the ideal way to set up sort of a serverless API, which is what we're doing, because you can use like different functions, serverless functions to call different things. But for this, I'm pretty much packing all of my API into one serverless function. And for that, we're using a switch statement. And this is just because it's a very bare bones demo, but you can sort of organize your backend in different ways. I won't be covering that now, but just as a note, I'm pretty much packaging our entire API into one function. So we'll call this serverless API. And we're going to use Node.js 16. This is because the code I wrote uses the Amazon SDK, but it uses the version for Node 16. And this is sort of like a negative of using serverless is Amazon only offers so much, so many programming languages, so many like environments. And if something changes, for example, they update how they want to do their software development kit, if I were to upgrade to Node 18, this just wouldn't work. So this is just like a note that if you're using serverless, so stuff like your runtime, your environment is all up to your provider, which in this case it's AWS. And that's where you don't have as much control. So just a quick note, we're using 16, our architecture is x86, and for our function, we'll need to create an IAM role. We'll go to create a new role from AWS policy templates right here. And we won't actually use any templates, but we're going to set our role name as serverless API role. Once you have that, we can go ahead and create our function. No. Oh no, I have to go delete a previous role from when I created this before. Let me do that really quick. Y'all don't need to worry about this. But if you do want to see your roles, you can go to IAM. Here are the roles. The one that I want to delete is this from the past. You don't need to worry about this again, but cool. That's deleted, and now we'll create the function. Cool. So now you can see this very pretty, wonderful UI for AWS Lambda. This is our first serverless function, and if you go down, you can see there's some default template code, which I don't know why mine's not popping up, but yours should be there. It'll be like a little, I think, hello world, but that doesn't matter. So now we can see that we have like add a trigger, add a destination. And this is just like, hey, for us, in this case, we're going to be like, hey, when we call our endpoint, we want that to be a trigger to call our serverless function. And whenever you call a trigger, it sends something called an event to your serverless function. You basically use that event. It has like, for example, an HTTP request has like information, maybe like JSON data or something. And we're just sending that as a part of like our event information to this function, which you'll see more later. But just as a note, from here, we're going to go to configuration, and yours should be here. But if you go to permissions, this is our execution role that we just made in IAM, and we basically want to just give our role permissions to basically interact with our DynamoDB database, and also something called CloudWatch, which is basically just logging for our serverless function. We won't really cover that, but it is very useful, so it's good to show. But if you go to here and make sure you're on roles, you can go to this little box, add permissions, and attach policies. And here, there's a bunch of default sort of policies, and we're going to use two of them. One of them is called this Amazon DynamoDB full access. And if you check that, you can just search like Dynamo or something that will pop up. This basically just gives us permission to, edit our DynamoDB as we wish. So just add that permission. And the second permission we'll want to add is CloudWatch. And we'll want to give CloudWatch full access. And again, this is just logging. Very useful. If you want, there's another CloudWatch service that you can go to after we're done, and you can sort of see what's going on there. But if we just add this permission, you should see that we have them in this little table right here, these two. And yeah, that's pretty much it for our IAM permissions. So right now, if we just go back to Lambda, and we go back to our function, we're going to want to add some triggers. And these are pretty much just our endpoints. There are different ways to do triggers. For example, you could do a trigger, say let's say your database gets manipulated somehow. You could have a function to run. Hey, if your database gets manipulated, run this function to do something. In this case, we're just going to use our API to do that. So if we go to API Gateway, which is another Amazon service, we go to this. See this front page, and it has 4 API types right here. We have HTTP, WebSocket, REST, and REST private. We're going to be using the one that's not private. We're going to be using a RESTful API. So if you click build here, and just click through the tutorial screen, it'll have a bunch of like random default Swagger code. I don't know what this is about, but we just want to make sure we have REST selected, and we're going to do a new API. We're going to call this Serverless API. Wonderful. And then we're going to create. Very simple. Now we're at this blank screen, and pretty much here we're just going to create our endpoints. If you go to actions, there's these two things, create resource and create method. Create resource is pretty much creating an endpoint, and create method is pretty much saying, hey, what CRUD operation can you perform on this endpoint? Like a GET request, post, patch, whatever. So if we go to create resource, just to check if our sort of API is healthy, we're going to create a health endpoint and enable cores and create resource, and boom, we have an endpoint. So the great thing about AWS is that most of the coding and just boilerplate code that you have to do is pretty much abstracted away. You just get to click checkboxes and stuff. So we'll create another endpoint. Make sure you have this like root selected. It's kind of funky how this works, but we're going to create 2 more endpoints, products, and make sure you have cores enabled. And also, did it again, and products. And this is just like products is like everything in our like sort of inventory database. And then product is like each specific item. So if you can sort of guess what endpoints we'll be doing for health, if you go to create method, we can just create a GET request. And all we're going to do is like pretty much just if we call this endpoint, it'll send us back like a 200 code and be like, yeah, your thing is healthy. If not, an error code. So we click check and use Lambda proxy integration, and we're going to use our serverless API Lambda function. This is pretty much how we link it to our Lambda function. Like it's just typing that in serverless API, and this creates a trigger that will call our function and send it events. So it's as simple as that. And this is very, very repetitive. I'm just sort of going through to show you all the requests. For product, we're going to create a bunch of different requests. So we can do GET if we want to just say get a product. Post if we want to like add a product. And this is just to show you like very easy, just clicking checkboxes. Most of this code is sort of abstracted away. Because if we had to like write our own server and our own API, which you're kind of writing your own API when you're writing the serverless function, but most of this like sort of networking and just the boilerplate code, just abstracted. So we have our post request, and I'll create 2 more, patch and delete. And 1 second. All right. So we're going to create post and patch and delete, I believe is the last one. So patch, and again, very repetitive linking. And the last one, delete. And then our products will have a GET request. But yeah, very tedious. Then we're cool. We should just have all our endpoints and all requests. It doesn't matter too much. I'll pretty much be showing off like GET requests and post. But if you're following along, hopefully you're caught up. But after this, we pretty much need to like deploy our API. So if you go to actions, there's this deploy API. We'll create a new stage and we'll call it prod, short for production. It really does not matter what you call this, but deploy, boom, we have our wonderful API deployed. And this is the invoke URL. This is like the URL that we will be calling to sort of just like call our endpoints. So if I were to go to health here, We haven't done anything to our Lambda function yet, but if we call this, it says hello from Lambda, because that's all our Lambda function does. If we go to an endpoint, it triggers our Lambda function, but our Lambda function right now just outputs this little text that says hello from Lambda, which is the default code. So now what we want to do is we want to edit the code for our Lambda function. And just to note, on the left here, we're in stages, so you can sort of see your different deployments and change what deployment you have for your API. But we won't be worrying about that now. There's also a bunch of other configuration settings, logs, whatnot. So here's CloudWatch logs. You can turn them on if you want. But if we head back to our Lambda and we just refresh, we can go ahead and see that we have 6 triggers here from our API gateway, and you can see all of the endpoints here. And these are the 6. We had 2 GET requests, or 3 GET requests, patch, post, delete, so 6. And you can just see them there. Now, if we want to add our code, this is a lot of boilerplate code, so I'm not going to be typing it out all here. If you want to learn how to sort of write API code, you can reference the code. Again, there's different ways to organize an API and the function. So I'm just using a switch statement that takes the event from our trigger and just does some little manipulation with it. So on the GitHub, actually, I won't copy it from the GitHub, but it's on the GitHub repo that I linked at the end of the slides. So actually I will. Why not? But if you go here at the end of this, and I put a bunch of screenshots to like show you where to click, if I've been going too fast or whatnot, but just copy all this code and pretty much paste. And yeah, I'm just making it easy for you guys because this really is just a lot of sort of boilerplate. To take you through it, we're using the AWS SDK, so Software Development Kit. This is outdated in Node 18. There's different syntax for it, but oh well, we're using 16, so it works. And this is just for manipulation with our DynamoDB table and our endpoints. And going down here, this is just our switch statement. So again, this is kind of scuffed because I'm getting one event in and I'm just being like, hey, what's our method? Go to this function in my AWS Lambda function, which really is like a bunch of different functions for each HTTP method. So you can see like get, whatnot. But once you put the code in, we can just deploy this. The click of a button. Wonderful, it's deployed. And now if we go back to, say, our endpoint with health, there should be nothing there. If there is something there, that means there's some error, but there's nothing there. And to show you what we're actually getting back, I will be using Postman. If you don't have Postman, it's basically just a good way to test a bunch of different like network calls. One of them is HTTP requests. You can create an account for free. It runs in the browser if you want. So here I'm just gonna go call an HTTP request. Not with that. Go back to the API gateway. Copy this invoke URL. We paste this URL and let's go to our health endpoints. Move this over here and we click send. We should get a 200 OK response right here, which means that woo, our API is healthy and it's calling our Lambda function right. That's pretty much all we do in our Lambda function for that endpoint. And now if we were to try something like products with a GET request, we have no products because we have not added anything to our table yet. So if we go ahead and try to add a product, if you remember, our endpoint was post and product. Right, we can send a request. It's going to say internal server error. And that's because when we send our event, it needs a body for the post request. We need to know like what exactly are we actually adding to our database. And if you remember, we had like the product ID partition, and that's pretty much what's going to separate each sort of row in our table. You can imagine it that way, but right here, you can pretty much just look through that. Deletion. This is our patch request. So if you want to go ahead and test this, we can go to body for our post request in raw, and I just have some default stuff saved here. So I'll be adding this. I don't think this is in the GitHub repo right now because I haven't taken enough screenshots at it, but you can add this. We have our product ID, so we're just going to add item 10,001, product name, price, color, inventory, and this is all defined in our code and how we manipulate our DynamoDB or DynamoDB, which we're not focused on that. We're just focused on serverless. But if we send this, hopefully it does not say internal server error, but if it does, we can question what is happening. I don't think this is the error, but boom, boom, boom. These were no. So our API is healthy. We could fetch our product endpoint, and now our product's post request is not working. So right here, I have my post request as save product, and it is going to have our DynamoDB table name, which we have as product inventory, our item request body, save success. Sorry, I have no idea why it's not working. Post should be working. So for this, I might enable CloudWatch to try to figure this out. You can do like errors and info logs or whatnot. I don't know if I could figure that. Okay. I have to configure something else to get that to work. But pretty much, yeah, you can just call stuff with Postman and get the endpoints to work. I don't really know why this isn't working right now, but yeah, if there's like any questions, that's pretty much just saying serverless functions. The server's just abstracted. They're running like a node server on whatever machine or big hardware server they have running. It's just abstracted. So all you have to do is write functions. You can link AWS Lambda with like a GitHub repo and write code that way. But I was just using their like little mini IDE with Lambda. Right here. And yeah. that's pretty much it. You can see sort of like metrics and whatnot, but as for the demo, that's pretty much it. I would look into why the post request isn't working, but I have to do some more like IAM configuration. That's kind of funky. So pretty much we have our get requests working at least with health and products. So not post, but here we get 200 and yeah, products. So that's pretty much our demo, pretty much our workshop. Anybody has any questions? We're gonna have pizza soon. If Satyan comes back, and the pizza man did not kidnap him. But yeah, that's it. So, back to our slides. No, where's our slides? There we go.
If you wanted to connect GitHub with code, how would you do that?
All right. So first off, create a GitHub repo, and then you're going to need to hit a bunch of like SSH keys and whatnot. I didn't cover it in this demo because it would be like overcomplicated, but here instead of using their like code, you pretty much put your own into the repo. If you go to configuration, remember, I haven't actually set this up myself, yeah, but it's somewhere in this menu. I forget where I find it, but you pretty much have to set an SSH key and configure it to basically work with this. But yeah, and that would also require some like finessing of the IAM permissions. When you're doing like sort of security with this sort of thing, say connecting your GitHub, that's sort of the tedious part of using sort of just like a GUI instead of doing the code yourself. So yeah. But any other questions? All right. Well, again, thanks for coming. If you can fill out this form, we can have food, probably pizza next time. But yeah, super appreciate y'all being here, especially on midterms week. So that was Serverless. Thank you. You're good to go.
The pizza should be outside in the courtyard, and go down